Welcome students. In this class we shall be discussing algebra of continuous functions and composition of functions, that is continuity of composition of functions. Okay, so let us move further. So that is, what is algebra? Algebra is nothing else but addition, subtraction, multiplication and division. These operations involving the functions, that's it. Okay, so suppose if f and g be two real functions which are continuous at real number c, okay, continuous at a point c. If f and g are continuous functions at point c, then we can say that the sum of two continuous functions is also continuous at c. If f is continuous at c and g is also continuous at c, then we can say that the sum of f and g, sum of two continuous functions f and g, f plus g, will be equal to will be continuous at x equal to c. Okay, that is what we mean by this. Okay, the sum of two continuous functions will be continuous. Okay, sum of two continuous functions is continuous at their common domain. Okay, same way, difference of two continuous functions, the difference of two continuous functions is also continuous at x equal to c. Difference of two continuous functions is also continuous. Product of two continuous functions f into g is also continuous. If f is continuous at c and g is continuous at c, then f into g is also continuous at c. And if this happens for each c belong to R, then we say that f and g are continuous throughout. Sorry, f into g is continuous everywhere. Okay, same way, f by g is also continuous at c, given that the denominator part, that is g of x or g of c, is not equal to 0. G doesn't become 0 at that particular point, because in that case this quotient function will not be defined. Okay, so the quotient of two continuous functions is also continuous at that point of continuity where both functions are continuous and defined. Okay, here when g of c is not equal to 0, when g of c will be equal to 0, at that time f by g will not be defined. That is why we exclude the region or the point c where the function g becomes 0. Okay, now let us discuss continuity of composition of functions. Okay, continuity of composition of functions. Suppose we have three sets, set A, set B and set C. Okay, now there is a point C here, x equal to C, and G is a continuous function which is defined from A to B. Okay, so here we have the image as g of c, right? Now there is another function, say f, which is mapped from this point g of c to this set c. Okay, so what you get here is the another continuous function is f. So what we have here is f of g of c, correct? So the composite function from here to here will be called FOG, correct? Now if g is continuous, if we say that g is a continuous function and f is also a continuous function, then FOG is also a continuous function. Okay, we are not going into the proof of this, but if g is a continuous function and f is also a continuous function defined in this manner, then FOG will also be a continuous function. That is, g is defined from a point C and f is defined from g of c. Okay, so in that case FOG will be a continuous function, okay, at c. Okay, If g of x is a continuous function at x equal to c, if g of x is a continuous function, if g of x is a continuous function at x equal to c, and f of x is continuous at x equal to g of c, okay, the domain of f will be the range of g, okay, then fog of x is continuous at the point c, okay, fog will be defined from a to c. That is what we mean. Now let us look at different problems relating to continuity of composition of functions. Okay. Prove that every rational number or every rational function is continuous. We know that rational function, say suppose f of x, let f of x be a function, okay, be a rational function, then that will be equal to, say, a numerator by denominator form, right? Rational means it is numerator by denominator form, p of x by q of x, right? It is equal to p of x by q of x, where q of x is a non-zero quantity. Okay, now we need to show that this function f of x is continuous. Clearly we know that, see, numerator is a polynomial, right? Clearly p of x and q of x are polynomials, and hence are continuous in their domains, right? Are continuous in their respective domains, are continuous in their respective domains, okay. Now f of x, what is f of x? F of x is a composition, sorry, it is a quotient. F of x is a quotient of two continuous functions, right? Fx is a quotient of two continuous functions, and hence f of x is also continuous, right? So therefore f of x is also continuous, correct, for all real numbers except where x is equal to, except where q of x is equal to 0, okay. So that is fx is also continuous for all real number. Fx means a rational function, so every rational function is continuous. So every rational function is continuous. Okay. Next, let us look at example 17. Discuss the continuity of sine function. This is a very important problem. Okay. Sine function. Okay. What is there in this? So let us take the function f of x equal to sine of x. We know that the function sine of x is defined on all real numbers, right? It is defined from minus infinity to infinity. The domain is R. Okay. So sine of x is defined on all real numbers. Sine of x, sine function is defined on all real numbers. Okay. Now we shall use a special approach to prove this. Okay. So first of all, let C be any real number, and if I prove that f is continuous at that point C, we can say that it is continuous at all real numbers. Okay. So let C be any real number, okay. Let C be any real number. Now Again, we will be taking a special assumption. Now let also assume that x is equal to c plus h. Now h is a very small quantity, very small quantity. What happens when h is positive? When h is positive, x will be greater than c, correct? And when h is negative, x will be less than c. Okay, so what happens that when h is positive, x will approach c from the right, and when h is negative, x will approach c from the left. Okay, that is the concept. So therefore here let us define the limits as x tends to 0, what happens to, or sorry, as x tends to c, what happens to h? H will tend to 0, correct? Now let us use these concepts. Now let us consider, to prove continuity, let us consider f of x limit x tends to c f of x, that is equal to limit x tends to c sine of x. Okay, so this can be replaced by limit, see x will be replaced by c plus h. So as x tends to c, h tends to 0. So as h tends to 0, x will become c plus h. Okay, sine of c plus h. I have made the assumption and changed the supposition. Okay, now what I get here is this will be equal to limit of h tends to 0, sine of alpha plus beta is equal to sine of alpha plus sine of beta. Sorry, sine of alpha plus beta equal to sine alpha cos beta plus cos alpha sine beta. Okay, so that is sine of c into cos of h plus cos of c plus, sorry, into sine of h. Okay, now this will be equal to sine of c into limit h tends to 0 cos of h plus cos of c into limit h tends to 0 sine of h. Okay, here this is a constant quantity, it is not dependent on h, that's why it is a constant quantity and therefore comes out of the limit. Okay, now we know that limit h tends to 0 cos x. Okay, limit, we know that limit x tends to 0, cos of x will be equal to 1. Okay, and limit x tends to 0, sine of 0 is equal to 0, right? So therefore what happens here, let us see. So this becomes sine of c is sine of c, and limit h tends to 0 cos of h will, this concept h tends to 0 cos of h, that will become 1 plus cos of c into limit h tends to 0 sine of h, and that is 0, right? So therefore what we have finally is sine of c, correct? And that is nothing else but equal to f of c, right? When you put x equal to c, that is sine of c, f of c is sine of c. So therefore we can say that the function is continuous for all real numbers. Okay, so therefore limit x tends to c f of x is equal to f of c, and therefore f is continuous for all real numbers, that is sine function is continuous for all real numbers. That's it. Okay, this is what you need to know. This is applied somewhere. Okay, at these two places we have applied the formula of limits. Next, let us look at example 18. Example 18. Here we need to show that or prove that the function defined by f of x equal to tan of x is a continuous function. Fx equal to tan x is a continuous function. Okay, we need to prove this for its domain, on its domain. Okay, so now how to prove this? Okay, let us take f of x equal to tan of x, and we know that it is equal to sine of x divided by cos of x. We have shown that sine of x is a continuous function. Similarly, we can show that cos of x is also continuous function. Okay, here such that where cos of x is not equal to 0, right? Cos of x is not equal to 0. Cos of x should not be equal to 0. That is, x should not be equal to odd pi by 2s. Odd pi by 2 means 2n plus 1 pi by 2. Okay, x is not equal to odd pi by 2s. Now, clearly sine and cos are continuous functions. Clearly, sine x and cos of x are continuous functions, right? Therefore we can say that tan of x is also a continuous function. Okay, because composition, sorry, not composition, this is quotient. This implies tan of x is a continuous function. Okay, because we know that if f and g are continuous functions, if f and g are continuous functions, if f and g are continuous functions, then f by g is also continuous, provided that g is not equal to 0. G of x is not equal to 0. Okay, that's it. So therefore tan of x is a continuous function. Let us go for the next example, example number 19. Example number 19. Here we have f of x equal to sine of x square. Okay, f of x is equal to sine of x square. Okay, now it is something like, say, sine of square of x, right? So it is a function of a function. It is something like a composition of function. Now square function is a polynomial function, correct? So let me take this as g of x. Square function be taken as g of x. Okay, so let g of x be equal to x square. Okay, so what becomes, so then what is f of x? F of x becomes sine of g of x, sine of g of x. And let sine of something, sine of x be equal to, and sine of x and h of x is equal to sine of x. Okay, we will take that. The outer function will be taken as h and the inner function will be taken as x square. So clearly we know that g of x is a polynomial function. Okay, clearly g is a polynomial function, and this implies it is continuous. This implies it is continuous. And h is sine function, also continuous. Correct? Because it is sine function. We have just proved that sine function is continuous. So what happens is f of x, now f of x can be written as sine of x can be taken as h of x, h of g of x. Okay, that is equal to h o g of x. So f is a composition of two continuous functions, and hence f is continuous. Okay, f is here f is a composition of two continuous functions. So therefore f is continuous. Okay, that's it. F is continuous. Shall go for the next example. Hope this is okay with you. Composition of continuous functions is continuous. Next example is example 20. Okay, here also we can say that we have another function f of x. F of x is given as, say, 1 minus x plus modulus of x, the whole modulus. Okay, this is a function. Now let me take the outer function modulus as one of the functions. Let me take g of x equal to modulus of x. The outer function is taken as g of x. Okay, and the inner function is taken as, say, h of x. Inner function is taken as h of x. Now h of x is equal to 1 minus x plus modulus of x. Okay. Now clearly modulus function is continuous. This function, right? We know that modulus function is continuous. We know that modulus function is continuous. Now what happens here? What about h of x? When you look at h of x, we can see that it is formed of two functions. Okay, this one is a polynomial function, a linear polynomial, and then this is the modulus function again, right? So the polynomial function is continuous and the modulus function is also continuous. So this is sum of two continuous functions, and hence h of x is also continuous, right? H of x is also continuous. We can say that here h of x is the sum of two continuous functions. Therefore h of x is also continuous. Now f of x is nothing else but g of h of x. F of x is equal to g of h of x. Okay, g of h of x. So therefore we can say that, so this implies f is the composition of two continuous functions, So this, therefore f is continuous. Okay, that's it. We shall see in the next video.